more vocabulary terms. Keep them straight. Make sure you can draw them. Parallel lines. You dealt with that in algebra last year. You probably did like graphing parallel lines. Slopes are the same. All right, I'm going to do it from the geometry side right now. If you take a look at the definition, coplanar. Coplanar, they're on the same plane. We talked about that term yesterday. These two lines would be on the same plane, but they will never intersect each other. So can you do me a favor, draw that cube we had up yesterday? All right, draw me another cube today. Okay, remind me from yesterday, how many planes did I just draw up with this cube? How many planes up there? 6, right? 6. All right, so pick one of those planes, of those 6 planes right now, and pick 2 lines off the plane that don't intersect. They're parallel. Okay, so they got to be coplanar on the same plane, but they can't intersect each other. All right, so give me a set of lines right now that you think are parallel in my diagram up here. Starting us off right today. 8. Char, start us off right. What do you got? CD is parallel with what? Did you say CD? CB, sorry. We'll go with CB. My bad. CB and? I didn't put a letter there, did I? CB and? HA, yep. Now, notice I didn't put anything in between. I do not want to write the word or the words is parallel to. I want to actually use the symbol now. Were you exposed to the parallel symbol last year? No? Okay, that's fine. Ready? Here's the symbol I want to start everyone using to say these two are parallel to each other. It's 2 vertical lines that look like that. There's your symbol for parallel. Okay, so make a little note there, because I don't want to see you guys write out the word parallel. I want to use the symbol. Okay, symbol for parallel. Well, let's give you another pair. I'm not satisfied. Not in an above average math class. Give me another pair. 15. What do we got here? Alexi? Say that one more time. I'm sorry. EF and H. A. Good deal. Yep. Any questions? Okay, I'll give you about a minute right now. Using my diagram here, find me a pair of lines that are parallel to each of those 3. So AC is parallel to what? EF and AD. Find a set of lines in that diagram that are parallel to the given lines. Let's go parallel to AC. 18. Marie?
That's Lily.
ACN?
No, my name is Lily.
Lily, I'm sorry. That's me. It won't happen again. Go ahead. Thank you. Lily, go ahead. ACN. Line DF. Good work. Thanks, Lily. How about EF? 12. So many people here. Finley. BC. Good work. And finally, how about AD? I believe there are 2 responses I would accept here. All right, so if you don't have one, I'll tell you the other. 18, parallel to that. Lily. Line CF. Good. Anybody have line BE? Because you can, perfect. So CF or BE. Good work, everyone. All right, everyone good? Parallel lines? All right, now I'm going to probably go on to the next one, which is probably the most confusing out of what I'm going to show you between yesterday and today, and that's called skew lines. If you read the definition here with me, they can't be on the same plane. They can't be parallel, and they can't intersect. So probably most of you, like me, are asking yourself right now, what the heck's left then? All right, what the heck is left? Here you go. Let's do a little... All right, here we go. Hold this bad boy up over here. Hold it up. So everyone can see it. Here's your cube. Hold it up. Take the cube, right? Thank you. You keep your hand just like that. Thank you. All right, you got one job. Okay, everyone's got my cube I had up there. So I have to pick 2 lines on this cube that aren't in the same plane, aren't parallel, and don't intersect. How am I going to do this? Everyone ready? Everyone see this line right here? All good? See my second line coming right there? Are they in the same plane? No. Are they parallel? No. And remember here, we're in 3-dimensional space. Are they intersecting? No. These are skew lines. Everyone see that? These are skew. Not in the same plane. Certainly not parallel and not intersecting, as you can see right here. They will never intersect. Okay, everyone got skew lines? All right, so use the diagram again. Let's do all 3 of these together. AC. Can you pick a line that would be skewed to AC? Now remember, your paper's in 2 dimensions. Like if you draw out the lines, of course they're going to intersect. But you got to imagine this in 3 dimensions, like we're holding this in our hands, and oh, they'll never intersect that way. So AC and what other line up there would never intersect, never be parallel, and not on the same plane. It would make them skew. Anybody want to throw it out here? I'm not comfortable calling on anybody with this thing. Anybody want to give me something that's skewed to AC? Okay, let's roll, Bailey. BE, love it. Yep, BE, definitely. Anybody have another one? AC, I was going to say EF. EF would be, right? Cormac, what do you got?
I was going to say
DE, yeah, perfect. Not on the same plane. Now, look, hey, I know, like, I said EF. Well, hey, look, you extend AC and EF. Look, they intersect. No, that's not how it works. Yeah, of course they intersect on your paper. But if I put this in front of you and I put my pencil here and my pen here, they're never going to intersect. Okay, they're never going to intersect. How about EF? I kind of just gave that one away, huh? EF, anything you want to tell me EF is going to be skew with? Not in the same plane, not intersecting, not parallel. EF and Cormac? AC, yeah, again. I gave that one away, huh? And finally, how about AD? Alyssa, go ahead. EF, love it. Yep. Yep, that's fine. And there's more. Just as long as they're not going to intersect and be on the same plane. All good with skew? Great. Next one I'm going to go through pretty quick. Parallel planes. 2 planes that don't intersect. Okay. If you use my diagram here, there's only 2 that are parallel, right? They cannot intersect. So yesterday, how do I name a plane from yesterday? How do I name a plane if it's got no capital letter in it? How many letters? 3, right? 3 letters. So here you go. Name me 2 planes up here that are parallel, please. Name 2 planes in this diagram that are parallel to each other. 17, what do you got, Dylan? Well, I need both to say that, yeah, that they're parallel. Just can't name one. It's got to be parallel to another. Okay, well, ready? Everyone ready? Plane ABC, and let's use our symbol now. Parallel to, what's it? Dylan, go ahead. Plane DEF. Good work. There you go. Good work. Everything else, there's no other parallel planes here. All right, I'm going to blow some minds here. How in the world, number 8, can a line and a plane be parallel? I get 2 lines being parallel. I get 2 planes being parallel. How can one be parallel to the other now? Easy. Go back to my diagram. Dylan just gave us these 2 planes, ABC and DEF, are parallel to each other. We're all agreed upon there, right? All right, so how can a line and a plane both be parallel at the same time? Here's how. You take one of those planes. So let's take plane ABC. It will be parallel to any line in the plane that it's parallel to. All right, so remember, plane ABC was parallel to plane DEF. Pick any line in DEF, and it will be parallel to the other plane. So we can take DF. We can take EF. We can take DE. If 2 planes are parallel, one plane is parallel to any line in the other one. Make sense? All right, so if 2 planes are parallel, one plane parallel to any line in the other. All good. All right. Now we get to the decent. Not that that wasn't decent, but yesterday I went off and I said, look, when you write a line, you have to have what on them? Arrows. And I said, you take those arrows off, that's a totally new vocabulary term. And here it is. You take the arrows off, it's called a line segment. A line segment. So what I need you to draw right now for me is a line segment. A line segment has endpoints. Endpoints. Let's call these endpoints C and D. What's in between? Infinite points, right? Infinite points. So let's put some more points in between. H, I, J, sure, whatever you want. Naming it now. Yesterday, it didn't, yesterday when I had this and I put all the points on here, C, E, D, it didn't matter if I called it C, E, D, E, C, E, D, right? It didn't matter. I just take 2 points and throw it on. It does matter now, though, for a line segment. When you write it symbolically, you got the line segment symbol, just like we had the mini line yesterday. Now, you can't just throw any points on there. You have to put the endpoints underneath. All right, you have to put the endpoints to name a line segment. The order doesn't matter, but it has to be the endpoints. I cannot put any of the points in between. That is line segment CD or DC, no other name for it. Okay, you name a line segment by its 2 endpoints. Questions there? Ooh, uh-oh. Some people are going to get nervous now. We're going to do a little algebra. Woo! And geometry in the same problem. Draw. Somebody read that correctly for me. What's that say? Draw. Line segment EG. So what's that telling me about E and G? Those are my endpoints. Here you go. Endpoint E. Endpoint G. Line segment EG. F is a point somewhere on that segment. Does it say where? Nope. So go ahead, everyone. Put F, point F somewhere on that segment. Does not matter where it is. Middle, beginning, end, wherever. So everyone's clear with the diagram. Okay, now let's get crazy. If EG equals 100, notice what I just took away there? What did I just take away on EG? What's not there anymore? The line segment symbol. If you don't see it there anymore, we are now talking about the length of it. You do not see the line segment symbol anymore. They're telling you how long it is, the length of it. So EG, this whole thing has a length of 100. 100 what? Doesn't matter. So this whole thing, however you want to show this, this is how I show it. I'm not expecting you to do the same. But this whole thing has a length of 100. EF. Notice I dropped the line segment symbol. Has a length of 4x minus 20. So on EF, I'm going to put 4x minus 20. FG, notice I dropped the line segment symbol again, has a length of 2x plus 30. Usually in here you have one job, but this problem you have 3 jobs. I need to know what's the value of x, how long is EF. Now, hey, don't tell, oh, that's an easy one. It's 4x minus 20. No, I want to know like a number, please. Like it's 15, 18, 20. Don't tell me 4x minus 20. I want an actual length, please. And then the same thing for FG. How long is FG? Woo! Using all this information, can you come up with something for me to solve for x? That's what I'm looking for now. Can you come up with all that information? You know the lengths of all the segments, the 2 smaller ones and the whole one, you know the lengths of. Can you come up with something for me to solve for x? This is where I need you to be. Whew. You know the 2 smaller pieces, and you know the full piece is 100, the length of 100. This is where geometry and algebra mix together. Anybody, if they think, I don't want to call anybody here, first one here. Anybody think they have a decent something for me to solve for x? Going? Think you got something going?
25.
25. Where are you going here? I need something to solve for. I just can't have x. You need to write something out for me that says this equals this, so I can solve for x and go from there. I don't want to guess and check. Okay. Anybody got something comfortable? Micaiah, what do we got? Okay, stop right there, please. 4x minus 20, which is EF. Add on to that the other part, FG. And what do you know about the whole thing there, Micaiah? Should be equal to 100, which I gave you at the beginning. Does everyone see where that's coming from? I have this piece, EF, add it together with FG, gives you the whole thing, which we know is 100. I don't know if anybody tried to put 4x minus 20 equal to 2x plus 30, but we don't know these are the same lengths. So I can't set these equal to each other. That's a no-go. Can't set them equal. Everyone, are we all right here? I know for some of you it's like, that. Of course, it's pretty easy. I get it, but some of you are like, whoa. We all go know how I added both together and got the whole thing of 100. All right, from here, I can't help you. If you're in this class, you know, your teacher thought highly of you last year to put you in this class, I can't help you solve this. Come on. I don't have time to go review all that. Add your like terms, 6x plus 10 equals 100. Subtract 10 on each side. 6x equals 90. And then divide both sides by 6, right? When you get the value of x, let me know. Take your time when you get the value of x. 3 when you're ready there.
15.
It's done. 15, good work. Yep. Remember I said you had 3 jobs? Now what's the length of EF? How can you use my value of x now to find the length of EF? Don't tell me the length of EF. Just tell me how you can find it now. Oh, relax. You're done. Stop showing off. Finley. Yep. So I'm going to take 4x minus 20, plug in x, and EF will be, when you're ready. That's not annoying out there. Cormac, when you're ready. 40, good work. And now I need the length of FG. You don't have to plug in x. If you know the whole thing's 100, right? We just found 40. When you're ready there, 5. When you're ready there, Jared? 60, good work. Anything? That's where we got to be now. Okay, when we mix in the algebra with your new geometry terms. Anything you want to throw by me? This will be on the quiz, definitely. Something like this. All right. Just to make sure we got this down. Can you draw RS? What's that saying? Draw what now? Line segment RS, where R and S are the midpoints. This is what I've been talking about, guys. Being able to draw. I don't care you know the definition. Don't care. I need you to be able to draw this stuff. Point P is somewhere on there. So throw point P somewhere on there. All right, everyone see I'm dropping the line segment symbol, so now you know that's the length of it. So the whole length of line segment RS, 24. And the length of RP is 10. Find the length of PS. All right, find PS, the length of PS. Can I get your thought? No variables here, right? I just want to make sure you understand this whole concept of length, putting things together, taking them apart. Your plan to find PS? 2, 1, going deep. Lauren, your plan? Yeah, the whole thing's 24. One piece is 10. Let's subtract it. So PS has to be 14. All right, good. One last piece here. Anything you want to ask before we end it here? All right, this is a term that you're going to see all year long. This term's congruent segments. And here's the bottom line with congruent. Two segments are the same length, but I actually don't know what the lengths are, but I know they're the same. Okay, that's what congruent is. You don't know if it's 7 inches, 7 inches, 18 feet, 18 feet, but you know what? I do know they're the same length, which makes them congruent. I just don't know the length. So can you do me a favor right now? Draw a line segment CD underneath where it says picture. Draw a line segment CD. And then right underneath it, I want you to draw a line segment EF that looks about the same length as CD. All right, so you have two line segments, CD and EF, separate from each other, that look like they're the same length. All right. Now, when you are looking at your textbook, a test, a quiz, how are you going to know they're the same length if I don't have units on it? You are going to see markings now on the diagrams, markings. Here are the markings that say that two segments are congruent. You're going to see what are called hash marks. See those? I don't need to know how long they are. Because I see the hash marks, they're congruent. They have the same length. Okay, because I see the hash marks. How do I write that they're congruent? Well, how do you write? Go ahead. Line segment CD. Jot that down. Line segment CD. Give me a little space in between, and then give me line segment EF. Now the congruent. You know parallel now from today. Anybody know the congruent symbol? Want to show off before I reveal it? Anybody know the congruent symbol before I show it off? You know the equal sign, right? Okay, that's part of it. You got the equal sign. And then on top of the equal sign, sure.
Does it have like a slash through it?
No slash. Something on top of it. This symbol right here. No, it's not called a squiggly. Have some self-respect. Don't be an embarrassment to the math community. It's not called a squiggly. Anybody know what that's called? Maybe from your foreign language? Tilde? No? All right, it's called a tilde. I don't care. But that whole thing is the symbol for congruent. That's what we're going to start using. Anytime two segments are congruent, we put that symbol. Never, and you tell me why, never will we say two lines are congruent. Never. Why? What do we know about lines? They're infinite. They can't be congruent. All right, the only thing for now anyway, we're going to put more things congruent, but for today anyway, the only things that are going to be congruent are line segments. That's it. Well, I got a question for you, above average kids. Don't put this on your paper, but let's say in the same diagram as CD and EF, I had these two smaller ones, AB and XY. And let's say they were congruent to each other, but not congruent to these two. What do you think I would see on those? Because I don't want to put 1 and 1. I don't want to put hash marks on those because that would mean all 4 are, but they're not. Cormac, what do you think? Darn right. I'd see this instead. All right, so just be aware of that. If separate segments are congruent, you're going to see double hash marks. All right, let's finish this off right so you can start the assignment. Last one. Which one of these 4 is incorrect? Whoa! What do we already see on there? Everyone see the hash marks? What's that telling you right now? Just by looking at the diagram, I'm going to call on somebody here. Just by looking at the diagram, what do you automatically know? All right, just based on the markings. What do I automatically know about this diagram is true? 3?
Both of the line segments are congruent.
Which ones? Name them. I got a ton up here.
A, B, and CD.
A, B, and CD are congruent. They have the same length. That's what I automatically know by the hash marks. Everyone okay? Because that's the habit I need you to get into. I look at a diagram. I see these markings. Oh, they're congruent. That means they have the same length. So which one of these 4 is incorrect? Relax. Number 1, true or false? Is AB congruent to CD? Yeah, and the easy answer is because the hash marks are on that, right? AB equal to CD. True or false? And remember, what's that mean when I take the line segment symbols off? They have the same length. And if they're congruent, they have the same length. So that's true. Ooh, here's a controversial one, the next 2. Is line segment AC congruent, has the same length to BD? Ready? Well, let me help you out here. AC, how is AC formed? I take AB and add what to it? What do? I take AB and add what line segment to it? To get AC, what do I have to add on to AB? I add on? Everyone agrees, BC? All right. How do I get line segment BD now? I take CD and add what to it? BC again. All right, stay with me. What do you know about these 2? AB and CD, what do you know about them? Look at the diagram. They're the same length. They're congruent. And what am I adding to both of them? The same length. So what do you know about the holes then? They have to be equal, right? If these 2 are originally congruent and I'm just adding on the same thing to both, don't the whole things have to be congruent? Yep, so that's true. I'm looking for the incorrect one. So the incorrect one, AC congruent to CD. That is not true. That is not true. Okay, 2 parts to the assignment tonight. First part is the bottom, and that should read page 9. Please change that. It should read the bottom of page 9, which is the page you're on right now. And then you go to the textbook work on Google Classroom. All right, let's get rolling. Let's see, this is period 2. Oh, plenty of time. We got over 10 minutes. Over 10 minutes. Only day 3, but I've thrown a lot at you already. Don't worry about explaining. Just write true or false, please. Don't worry about the explanation. The explanation is, I looked at the darn diagram. It's your call. You let me know. We'll figure out a day and time that we can see. Okay. So probably it's gonna be Tuesday on next week. We'll figure out a time. What? Do you have 3 periods? For study all this stuff? We can do 4th Tuesday if you want. Is that all right? Okay. And I want you guys to work right up to the bell here, right? Don't pack up early, head to the door. Right, just work right up to the bell. It's up to it. No. Yeah, that's it. That's not a typo. What's BD has a length of 12, so what can you do if it equals 4x? You can set it equals to 12. So 4x equals 12. See what I mean? Yeah. All right, yeah. We're wondering here about number 7 here, everyone?
Yeah.
Okay, when I drop the line segment symbol, that means the length of it, right? So the length of BD is 4x, and the length of still BD is 12. So what can you do with the 4x and the 12? Oh, I don't want to add them together. How long is BD? It's 12, right? and it's 4x. So I can take 4x and set it equal to 12. All right, I can take 4x. Here's what it said. Hey, take a look. Take a look. I get it. First, you know, here's BD. First, you know that BD is what? 4x. And it also has a length of 12. So that 4x is equal to 12. Okay? And then you go from there. You're overthinking it. Now you're overthinking it. Have a good day, guys. Behave. Stop by if you need anything.